yours.
Thanks, Tamara. So yes, as you can see, and as Tamara said, I'm Richard Ostridge, Senior Product Engineer in the Geomatics Division of Leica Geosystems here in Switzerland. I joined Leica in the UK after about 5 years in the industry, which was split between working for a major engineering firm and studying civil engineering. After a few years at Leica in the UK, I was lucky enough to join the product management team and relocated to Switzerland. Then in the sort of 10 to 12 years since, I've had numerous roles in Leica in various countries as well. So I've been quite lucky, but typically I've stayed working within the survey industry, focusing on our field software, total stations, multi-stations, and GNSS products and solutions that serve this industry. I'm really delighted to have been invited to join you all today. I'm excited to say a few words about some of our technology and then hand over to Jane, who'll cover more about how this technology can be used in some real-world examples. Now, I'm sure many of you know Jane, but for those who don't, Jane, would you like to introduce yourself too?
Thanks, Rich. Hi, I'm Jane Cooke, and I'm the National Technical Support Manager at C.R.Kennedy based in Melbourne, Australia. My survey background was mainly in establishing and processing GNSS monitoring networks in tough, inaccessible locations all around the world. I then joined Leica UK, working in technical support with the System 500 and the TPS 1100. And in 2002, I moved to C.R.Kennedy in Australia and have now worked for nearly 20 years supporting Leica's surveying equipment. Back to you, Rich.
Okay, thank you. I want to start with just a little bit of history. This image that you see in front of you is an image that many of you might recognize, and actually a scenario that some of you may even have been in the past. We're looking at laser scanning about 20 years ago, which is when laser scanning was truly in its infancy. The black box we see in front of us, that's the 2400, and it was actually able to scan at up to 400 points per second, truly amazing at the time. However, it did need a separate total station, laptop, external batteries, and let's be honest, a full crew and probably a big van as well. But despite that, it was undoubtedly revolutionary. And that word revolutionary is the one that I want to use to sort of link us forward as we move forward in time. Now, let's jump to 2013, because this was when we at Leica introduced the world's first multi-station, the Leica Nova MS60. It was a great step forward, and we quickly followed it up with the next step. It was just a couple of years later, we introduced the next generation of multi-station, the MS60, and then today we're informing you about another step, the new Leica MS60 multi-station. Now, before we jump into the specifics of exactly what's new and how to use it, or what it can bring, I always like to take it back to what is a multi-station. A question of where the multi-station came from or what it is. And for this, we'll actually start with the beginning. We'll start with the first multi-station, the MS50, the true first of its kind. With this, with the introduction of this instrument, we introduced a new class unique to Leica, the multi-station. And still today, it's the only system that combines the best available technology from robotic total stations with GNSS, with high resolution imagery, and with laser scanning, all in one instrument. We call this merging of technology, merge tech, but it's much more than the merging of technologies. It's, I guess you could say, the merging of possibilities. It's a robotic imaging, scanning, smart total station, but of course that would have been a bit of a long name, hence multi-station. Now, after the MS50 came the original MS60. It was a nice step forward, but it kept true to this merge tech and multi-station concept. It improved things with refined algorithms, better prism performance, and of course, the latest field software like a Captivate. But it did stay true to the multi-station concept. Now, I could probably happily spend the whole webinar talking about the technology that sits inside the MS50, the MS60, and the new MS60, but instead we're going to focus on just some of the key points and then much more on how it can be applied. So if we don't go deep enough into technology today, then I apologize for that, but please do visit the Leica Geosystems website and take a look at the excellent multi-station white paper that you can find there. The new MS60 you see on the screen now this takes things a step further, but it's really about having this high-speed, high-precision sensor that provides you with complete flexibility and versatility to make the right decision in the field in all sorts of scenarios. I mean, it's about optimizing your survey data capture and stakeout processes all in one tool, one device which you'll utilize every single day on any site and for virtually any task. Now, hopefully, Tamara's just queuing up a short video for us so we can see it a little bit in action.
Sure, let me load that up, and I'll just take the opportunity now again just to remind you to please check your audio settings and your speakers.
This event today is to introduce the new Leica MS60, the ultimate all-rounder and the latest multistation from us at Leica Geosystems. This MERGTech empowered multistation is built to help you make the right decisions. For example, when inspecting surfaces, it generates heat maps automatically to help point you to problem areas. This unique instrument can scan at up to 30,000 points per second as it rotates in an all-new horizontal spiral scan pattern. Plus, it answers that age-old wish of automatic height reading. It really is the perfect tool for today's multi-surveyor. Generate accurate point clouds quickly, view them live in the field, and combine them with total station measurements as you focus on your work and let one of the world's best robotic total stations utilize features like dynamic clock to find and follow you wherever you go. Then, directly send these combined data sets back to the office, where Leica Infinity can help you to inspect and analyze them further. The highest end total station performance, 3D scanning, GNSS connectivity, and digital imaging. Experience this latest merging of technology with the new Leica MS60 Multistation. Okay, so apologies if there was a small bit of echo with the commentary there, but we can carry on. But before we go any further, I want to take the moment to share some of the key MS60 specifications with you here. The improvements or the changes, the additions, they're highlighted in red, but I want to mention just a couple that somehow mean more to me, some that jump out to me. One is a feature that we've always had on our multi-stations, and that's being able to define custom scan resolutions. I mean, it's a key example of our flexibility and versatility. You can input different or varying horizontal and vertical intervals, so it gives you full control. Example would be on a long linear project like a road, it's probably wise to have a tight vertical spacing, much tighter than the horizontal spacing. But there'll be scenarios where you need it the other way around, and that's exactly what we allow you to do. A great example of something that's new would be the auto height feature. It's finally here, having been requested for, I don't know, something like 20 years or more. And then we have Locate, a great system for anyone who considers security a concern. And I'll touch on those two a little later. But another feature I want to remind you about is over on the right-hand side of this slide. We have this small reminder that you can operate the MS60 directly on board with the CS20 controller and its 5-inch screen, or the CS35 tablet with its 10-inch screen. And you operate it in the same way. You're using the same software, the same interface, and the same interactions. So again, it's about choice and about versatility. Now, if we move on and start looking at the scan capabilities, then of course the headline is speed. Oh, didn't move on. There we go. Yeah, sorry. So if we look at the scan capabilities, we know this headline is speed, we know this headline is scanning, but there's more to it. Yes, we have new scan modes due to our new spiral scan pattern, which I'll mention a couple of times for sure, but certainly we'll talk about properly in a moment. We also have the ability to pause or start and stop a scan. For example, if a vehicle comes into your scene and parks up and obstructs your view, or if we need to turn to a more important task, now we can pause our scan, move away, continue, or sort of turn away, do the other work that we need to do, and then later on turn back and resume the scan from where we left off without losing any of our progress. Plus, we can repeat scan definitions. This means we don't need to manually redefine the scan again and again. We can just repeat the scan. So this is great for standard operating procedures and uniform scans. Plus, we can even save those scan definitions and pass them to colleagues, to other instruments, to make their life simpler too. Now, when we start to look at the scan modes themselves, we do still have the polygonal, rectangular, and manual scan area definitions that we had before, and they work with the existing up and down scan pattern of the previous multistations. But in addition, we've refined the full dome scan. We've added 2 new scan paths with a zenith scan and a band scan. And those last 3 I mentioned all use that new spiral scan pattern. I've mentioned this a few times, this spiral scan pattern, so it's probably time to really talk about it a bit more. It's a truly new pattern that complements this existing up and down scan pattern from the previous multistations. This pattern allows us to scan whilst the instrument's rotating in a horizontal way. So the instrument rotates horizontally at 360 degrees per second, all the while capturing scan points at up to 30,000 points per second. It works in, I guess I would say, quite a simple way. It starts at the top of your defined scan area, spinning horizontally, and then gradually it works its way down vertically, working its way down the area, creating this spiral pattern, hence the spiral scan mode name. Okay. A great example is band scanning. It's horizontal scanning and a great showcase for where this spiral scan is fantastic. Imagine you're doing some internal work where you need to produce quick floor plan profiles of rooms. As you can see in the pictures on the screen, you set up the instrument in the middle of the room. You just define a small band, and then in just a matter of seconds, the MS60's rotated a few times, done a few spins, and collected the exact point cloud that you need. So you can see on the screen, the steps are minimal, and the result is very helpful for sure. Another example of the spiral scan pattern is when scanning around the zenith of the instrument, so directly above the instrument. This new patterning allows us to optimize and become much more efficient. On the left, at the bottom, we see points collected around the zenith using the existing vertical up-down scan pattern of the previous multistations. We had a lot of overlapping points in these scenarios. We sort of had duplicated data above the instrument. But on the right-hand side, we see a clearer graphic. This shows how optimized our data now is for zenith areas. It's this new spiral pattern resulting in huge speed improvements, for example, when measuring the ceiling of a room or when measuring inside a tunnel. I think actually, that's probably all I'm going to say on scanning right now. So we're just going to hand back to Tamara quickly.
Thank you, Rich. So we have come to the first of today's poll questions. I will just load that up. Okay, so what we're asking is, what's the most important to you when you're scanning on site? It could be the speed of data collection and storage. It could be accuracy or flexibility of user-defined scan resolution, or it could be the ability to access scan data to check tolerances. Please select from one of the following. We'll give you a few moments to answer this. Okay. Let me share the results with you. Any surprises there, Richard, Jane?
Oh, no, it's good to see. I'm glad to see that people are, for sure focused on accuracy as professional multi-surveyors is key. But I like that the speed of the data collection is rivaling it now in second place. So I'm happy with that. I think that's aligned with what we hope. I mean, I don't like to say what we expect, but aligned with what we hope. So that's good. Yeah. Thanks for the feedback. Okay, so moving on from the poll question and moving away from scanning for a moment, I want to cover a couple of the additional enhancements that make the new MS60 different. And starting with maybe the obvious one, auto height. If we're honest, ever since laser plummets appeared in the 90s, people have wondered about using a disto for the laser plummet, myself included. It's one of the first questions I ever asked a Leica Geosystems representative. Now, we're pleased to announce that we have it. We've included auto height as standard with this new MS60 Multistation. And I'm convinced I'm not the only one who's walked across a field and forgotten to tape measure. I'm not the only one who's ever misread a tape or mistyped a number. Just being really realistic, but think about those time savings, that lower stress level and the reduction in human errors that come from a feature like this. I'm delighted that we have it and delighted that it's integrated into the Multistation. Another cool, much requested feature, maybe it changes from one region to another, is locate. Oh, Jane, I don't have control. Oh, I think Jane has control. Tamara, can you pass control back to me? Sorry. So yeah, what I was going to say is, yeah, the locate system. This is a great feature which has been added into the Multistation. It's actually available not just on the new Multistation, but it can be retrofit to the original MS60 as well. It's a powerful tool used for asset management and for tracking. You can track your instruments by GPS, assisted GPS, or Wi-Fi, helping you understand where your assets are. Of course, it's great for fleet management and reporting. Plus, if bad luck strikes and you need to find, chase, or recover an instrument, then you can increase this the communicated rate of its position all the way to up to once a minute, which aids you massively if you have to go into this hunt mode and go into this hunt situation where you're trying to find your instrument. Now, if the worst did happen and somehow the instrument was deemed unrecoverable, for example, if it had been transported overseas, then you have the control from your interface, from your panel, to remotely immobilize and lock down this asset, essentially rendering it useless for those who are handling it. Now, the more this happens, then the more thieves will start to realize that it's not a valuable asset to them, and they'll move on to softer targets. So it's a great feature, definitely, for anywhere where security or theft is a concern. Maybe you've figured it out or you've realized it, but I could happily talk all day about the features of these instruments. But first of all, that might get boring. And second of all, I definitely wouldn't be invited to work on another one of these webinars. So I'll try to quickly bring my section on the characteristics to a close. But before I do, just a few reminders. Yes, the MS60 Multistation is fast. And that's speed. That's not only when measuring points. It can go up to 30,000 points per second, yes, but it's also fast when we're using it as a traditional robotic total station. For example, due to that dynamic lock or the ability to track highly dynamic targets even at close range. It's just fast in so many ways. Plus, as with the previous Multistations, the new MS60 is designed with versatility in mind. It's designed for those who need speed and versatility. This whole range of measuring, staking, and checking use cases delivered and performed by this one tool, constantly trying to increase productivity. And also, this means it's not just increasing productivity, it's increasing utilization of your investment. Savings are made by not having multiple instruments with you in the trunk of the vehicle and leaving some in the vehicle whilst you use others on site. It's one tool that you'll use for all the tasks. So it's this utilization of your investment. It's the ultimate all-rounder. Plus, I deemed it so important, we've elevated it onto this slide here. We have this, one of the biggest wishes in the industry, one of the most demanded features, this auto height feature that's now been included too. So I think it's really a great tool, but whenever we talk about multi-stations, one question that often get asked is, where does this fit in my organization? Where does it fit? How do we use it? Where do we place it? Now, traditionally, we at Leica have provided equipment and services into sort of two big areas of the industry. One referred to as survey and another typically known as construction engineering. Within the survey world, we see technology advance more and more and more. Not just traditional total stations and GNSS, which of course do advance, but it's also scanning with the exciting RTC 360 and BLK range. But it's also mobile mapping with Pegasus, with UAVs. We're really pushing what can be captured. Then in the world of construction, we hear one word more than any other. We hear digitalization. We see it in our focus products like the Icon range of measurement and layout tools, which are focused on specific tasks for this industry, focused on handling digital data straight from the design to the field user. And then there's this drive, the constant drive of machine control. It's being continuously improved to increase our efficiencies in data management, in general site work, and of course, lowering the health and safety risk by utilizing those same digital design models and utilizing them instead of relying on manual work on wooden pegs. So with this survey's mass data collection approach and the construction industry's focus on digitalization, it's clear that rich data is what links these two worlds. But some would argue that personnel-wise and equipment-wise, these two areas feel like they're diverging. People will argue that for sure, but I would say that there's many of you on the call right now who sort of disagree with that divergence, who almost don't see that divergence, or at least they don't consider it a problem. And that's because they're engineering surveyors. They're the people that bridge the gap. They're the all-rounders, the professional multi-surveyor that works in and for both worlds. And it's this engineering surveyor that really can utilize the multi-station. Now, if we just think about some of the tasks that an engineering surveyor will be required to do during the life of a typical project, the list is huge. Data prep, control work, surveying, scanning, surface analysis, volume analysis, monitoring, DTM, stakeout, offsite construction, reporting, etc., etc., etc. I don't need to preach this to you. The list just goes on and on. So what the professional surveyor does on site, it really can be a huge variety. Today we need to be all-rounders. We truly need to be a multi-surveyor, and that's the place where the multi-station fits. It can help in each and every one of the tasks on screen. It's the ultimate all-rounder. So that's really brings my section to a close with my little pitch. I want to thank you for listening to me. Of course, I'm staying on the line and I'll be back for any questions later. But for now, I bring my section to a close and I hand over to Jane. And yeah, I just want to thank you for listening to me. So Jane, over to you.
Excellent, thanks Richard. The remainder of the presentation will be taking a closer look at the tasks of the engineering surveyor and how the MS60 can assist with each of these. This large Sydney-based site has the scope to demand all of the typical tasks of an engineering surveyor on one project. First, survey control must be established with the requirement to send this data to the relevant interested parties. Information must be staked out, and again, there's a need to receive data for this task and to produce reports following the task as a QA. The area is surrounded by existing infrastructure which will need to be monitored in some way, either continuously or at intervals. There will be earthwork movements that require volumetric surveys to be completed and reconciled, and these earthworks will need to be checked to ensure the levels are correct by using a DTM. As structures are built, there will be surfaces that need to be analysed, and many of the component parts for these structures will be fabricated off-site and need to be verified prior to being lifted into place to avoid lengthy and costly reworks. Of course, as a dynamic and evolving site, the control that's integral to the control is an integral part of all this positioning and needs to be maintained and updated constantly. All these tasks need to be documented in the reporting structure. As a 1-second total station, the MS60 is a perfect tool for establishing and maintaining a control network on site. With the onboard apps, Measure Sets and Traverse, it gives you an easy to follow routine that once the targets have been identified, can be completed by automated observations, saving you time and preventing eye fatigue. If adjusted control is required immediately on site, the Traverse app can reduce and distribute the errors of a traverse using the transit and compass rule. The results can then be published to a separate control job, so these updated control points can be distributed through SD card, USB, or Leica exchange data transfer, meaning that other users on site get the information instantly. For quality control purposes, a traverse adjustment report can also be generated in the field. The MS60 uses some familiar Captivate interfaces, the same interface as our survey total stations and GNSS receivers. The Measure app has been optimized for the large 5-inch data screen for data input, controlled by either touch screen or button press, whichever you prefer. Regularly required fields such as point ID, target height and code are easily accessible on one screen to save you time with switching screens to input information. Let's focus now on the road outlined in red. The surveyor needs to measure features along this road. The screen shows the template feature. You can build, save and load code templates that can be easily accessed to bring the codes you require to the fore in an instant. Any attribute information that is needed will appear on the screen as an input field when it's required by the feature code. To optimize your movements in the field, the code templates can be applied to an automated selection mode called zigzag, meaning that the code selection changes automatically as the observations are recorded, while surveying cross-sections of features such as roads. All of this gives a fast and complete data collection tool. Once the data is collected, switch instantly to the map or overview camera to verify that you have all you need before leaving the site to prevent the need to return. Once the survey is completed, the data can be sent back to the office for processing in any number of packages, including ListCAD or Neo, 12D, Microsurvey CAD, Civil 3D, and of course our own Infinity software. Data can be transferred directly from the field using Leica Exchange. This is a fast, secure service hosted by Leica Geosystems, which offers field-to-office and field-to-field transfer, meaning that office staff can be working on the data while a surveyor is on the road. And in this case, the data is accessed directly from Infinity, but it's also possible to access from the My World portal. The Multistation is an ideal tool for our engineering surveyor to measure volumes of objects, such as we can see here circled in red, but which for health and safety reasons mean you cannot access them directly on foot. As Richard mentioned, Leica first released the MS60 in 2013, and this is the model shown in the video. You can either choose to make manual reflexless measurements, but here it's easier to scan and create a point cloud. Choose the appropriate scan method for your job. A polygon is usually used for a stockpile. And then set up on one side, orientate, define the scan, and then set up on the other side and repeat again from there. You have a complete survey with a dense point cloud accurately modeling the shape. Combined with the Quick Volume app, an accurate stockpile DTM and volume can be quickly and safely obtained. We'll look at inspect surfaces in a little bit more detail later on. When working robotically, the user has a choice to use the rugged 5-inch screen of the CS20 or with a full keyboard, or the large 10-inch tablet. You can set up directly from XML files, IFC, CAD, Genio, or ASCII files. Importing this data directly from the designer means that it lessens the time required on data preparation and also reduces the possibility of making mistakes while doing this. IFC and CAD data can be filtered by isolating elements and layers respectively and simply to simplify the complexity of drawings to make it easier and quicker to identify the information you require. You can select that data textually or directly tapping on the 3D map. Using specialist road and rail and tunnel apps, more complex data can be used and taken directly from the design package. Once the data is staked out, a report can be produced on board the instrument through cut sheets or style sheets, and also later on if required in Infinity. When performing stakeout or other survey tasks on site, there will be many obstructions that block the line of sight from the instrument to the prism. This is another situation where the MS60 comes into its own. The field of view is enlarged, and moving targets which cross this fan will be detected and locked onto with dynamic lock and ATR+. You'll save time in both acquiring lock and retaining lock for longer. If you do lose lock, you'll quickly regain it and you don't have to stop and do a power search. Let's have a quick look at dynamic lock in action. We have a video here of our trusty surveyor going to site, getting all his high vis on and getting out his instrument. So we can see here that the instrument is locked onto the prism, and he's just going to bend down and just spray a marker on the ground, and you can see the prism goes out of view. But the instrument knows where the prism is, and as the prism returns back into that fan, it instantly picks it up and stays connected to the prism. We can see another situation here when you're out on a more complex site and you're picking up the prism on the side of this dozer. As it goes behind the wheel loader, you can see that the actual instrument loses the prism. There we go. And the instrument then does a quick search, looks at the prism and just sort of stops and then goes back along that fan. And as soon as it finds it within the fan again, picks it up immediately and locks back onto it. A lot less frustrations on site when using dynamic lock. Right, and now we have time for our second poll question. Tamara.
Thank you, Jane. Let me just load that up. Okay, we'd like to know what costs you the most time on site. What really holds you up the most while you're on the site? So you can select from one of the following. It could be losing lock to the prism and having to search for it, or you might find yourself waiting for scans to be completed. Or it could be the fact that you're going back to the office to get new set out data, returning to areas to collect extra data, or an inability to calculate results or produce reports on site. We'll give you a few moments to select your answer. And just a quick reminder, if the poll answering does not work for you, you can click out of this full screen mode. I'll give you a few moments. Great, I can see that most of you have finalized answering. So I'll close that and I'll launch the results.
Excellent. That's cool. That's probably what I would have expected in terms of what people are looking at, and that's because of the losing lock to the prism is one of the reasons why dynamic lock is so important now. But yeah, that's interesting results. Okay, so we're looking now at monitoring existing infrastructure which might be surrounding your site. So it's often the critical infrastructure, maybe in the form of existing buildings, bridges, tunnels, or railways. And the frequency of the monitoring of these tasks does depend on what's required. It could be at campaign intervals or continuous. Leica Geosystems have solutions across all the different requirements. And the MS60 is extremely powerful and efficient in this regard. We'll just have a look here at the TPS monitoring app. This may be one that not many of you have had a close look at. So the TPS monitoring app has predefined station setup groups for an automated resection, and it monitors point groups that can be timed to start at set intervals. So we're looking here about setting up the different point groups. For a short-term project that requires monitoring of points, the instrument can be left to actually collect the data without the need for the surveyor to be watching and controlling it constantly. The auto setup routine can be scheduled to repeat at any time, regularly validating the setup. Upon completion of the setup and the monitoring of the point groups within the TPS monitoring application, it's also possible to publish directly to the Geomos Now web portal to make the data accessible for analysis in an instant directly from the field. So we'll just look at it finishing off here. So we're finishing off our second point group. And now we're going to stop the monitoring process, and on the screen we can click to export to Geomos Now. And it even gives you a QR code to directly go and access that information. There we go. Geomos Now allows for graphs and charts and reports to be configured so they can be populated with the data remotely from the site by anyone with access to, so you can have an access to this on your tablet or on your PC. In order to create the graphs in Geomos, it's actually really critical to have good communications between the software and the surveying instruments And there's a couple of images here of some popular monitoring components that we have. And we install with our instruments comms boxes, as seen on the left there, and also the monitoring shelters. And these are an important part of making sure that the data is uninterrupted and flows straight through to the Geomos software. Now let's focus on monitoring an adjacent apartment block using a new method called different method called patch scanning, which again, many of you may not be aware of. This uses no targets, so there's no need to install any access platforms or working at height certification, etc. The scan patches are on different planes, such as the window head or the opening or the windowsill, and this facilitates looking at deformation in each axis direction. And it's frequently used when the engineer doesn't actually know the axis of the potential deformation or tilt. These results are also published directly to Geomos, and it's easy to check on any online device. The graph on the far right shows a month's worth of data with plus or minus 3 mil variance for median deformation, well within spec. Another case for patch scanning is where it might not be possible to install targets on, say, tram rails or on the road, as vehicles or pedestrians would knock them over. Again, no targets means a lower investment in accessories, no installation times and costs, and no ongoing maintenance to account for. This method delivers millimetric deformation measurements that are well within the spec of this project, automated to run daily without manual measurements. And of course, we have imaging on the MS60 telescope through the overview and telescope cameras. This allows us to remotely view the site via Geomos to understand why a measurement is not possible, such as a temporary obstruction to a target, and where site access may be difficult, costly, or even impossible. Furthermore, you can create a time series of georeferenced images within the project database. Now we'll have a little bit closer look at the Inspect Surfaces app. Essentially, we'll be comparing surfaces to surfaces or geometry or individual points in 3D, including flatness and verticality checks. Perhaps we have design geometry to compare as an as-built against a plane cylinder or a complex DXF or IFC file. We can also compare as-built to road or tunnel geometries or against previous scans. Traditionally, in a common example of concrete, it's poured and cured and measured with a post-processing analysis in the office later. And then for remedial action, you then would grind down the high spots, leading to cost, schedule, and budget overruns. Now you can float the concrete screed to the correct level using real time, using Inspect Surfaces, and the laser pointer from the MS60 to identify high points before the concrete is cured. And you can do all of this on site rather than later at a greater expense. As well as saving money, Inspect Surfaces is also used to assess for assessing stability and safety. In this example, we're looking at a sheet piling project where the engineer wants to understand the verticality and stability of the sheet piles. By scanning and then repeating scans, Inspect Surfaces between the two, you can actually generate a heat map of the differences. And this gives you very clear results, giving you confidence in the stability of the structure. We're now going to focus down on this area here, and this is a different, again, a sort of a different part, but often a common part of an engineering build. Off-site construction, prefabrication, DFMA is an increasing trend. Here we're going to use the Orientate to Object app to set up relative to an object such as this steel beam, which may not be aligned to the Z-axis. Scanning the object then allows us to ensure that it's built within tolerance. For further verification of the data, it can be seamlessly taken into software such as Infinity or Cyclone 3D Reshaper to allow for a deeper analysis of the data collected in comparison to the design. Here we have CAD design and a scan piece of steelwork. Cyclone 3DR will transform one set of data to fit the other and then show you a surface. Show a surface comparison to show how well this constructed parts fit with the CAD design. If you need to edit your field data from your Multistation, you can do this in Leica's Infinity Office software. This software is used to manage, inspect, and report on everything we do with the Multistation. We have the power to process and edit and update our data, and whilst keeping data of the survey data and the scan data intact and connected. If we edit or adjust TPS data, the scans will also be updated in position and height as the station setups are updated or edited. You can also create and code features from the point cloud and create or work with surfaces derived from these point clouds. We also so far haven't talked very much about the benefits of using the imaging with the MS60. This video is just going to show you how you can use some imaging taken in the field to acquire additional points you may have missed. So we're turning off the standard background images. This background reference was also picked up, processed in Infinity using drone data. And we have a survey here that was done, the background survey done with a GS18 and the rest of it done with an MS60. And we can see here that we've done some setups and we've got some scans. They're automatically joined together. You don't have to register them. But we're going to use the images. So what we're going to do is we're going to focus on picking up a point on the scan that we couldn't collect, that we didn't collect using the total station with a single point. We could pick up the cloud point, but we can also do it using images. So we find one point in multiple images, and then we click on that point in the two different panoramic shots. The panoramic shots were taken from the station setups when they were done. So we just accepted to do a station panoramic shot when we did the station setup. We now code our point, we can look at the standard deviation, and then we can give that point a new name. And this is then creating the point. And you can do this for as many points as you need in Infinity. And this is using the images. As I said, we could use the scan data, but it's also possible to use the images as well. And it allows you to pick up any points that you missed when you were doing field work. Just then using the layer manager to turn back on the point numbers and also the point symbols. And we can see when the symbols come back on that a lot of our points on the ground were picked up using the GPS. And the point on the building is then a created point, which has a slightly different symbol, and that's shown in location in situ. We can then export the data from Infinity, and we can do this in many, many different formats. We might want to export back to the field, or we can export in a DVX or an XML, or there's a lot of different point cloud formats as well if we wanted to just export the point cloud. So we can set where we're going to export the data and then create the file. When we export from Infinity to the field, we actually have the ability to use Connex to go to machine control or Leica Exchange to go to survey users. And these powerful collaboration sharing tools allow you to actually send data and not people. So it saves you a lot of time of actually getting the information and the data back out to the field. These will be covered a little bit more in an upcoming Infinity training session. So watch this space, and you've got my contact details at the end if you're interested in any further training. Thank you very much for listening to this information session on the new MS60, which we know to be the fastest and most versatile multi-station on the market. Now, back to you tomorrow for the last poll question.
Thank you, Jane. Okay, so we'd like to know if you had a Leica MS60 today, what would you use it for? Please select any of the following. So it could be DTM stakeout control, surface analysis, volumes, monitoring, scanning, or if it's something other than what we've outlined there, please feel free to answer via the chat function. And again, a quick tip, if the poll answering is not working for you, you may click out of the full screen mode. Give you a few moments. Great, I think most of you have answered, so I'll close the poll now. Let me share the results.
Okay, yeah, good. That's what we would expect, I would say, in terms of the scanning being the most popular, but regular total station use still sitting in there, and the surface analysis tool, which is super powerful. So I'm pleased to see those results. Thank you.
Great. Okay, we've recently received some interest in the new Leica Nova MS60. So we're giving our Australian and New Zealand customers an opportunity to trial the Leica Nova MS60. And by trial, what we mean is we're actually giving an opportunity to take it home and test it out on a particular project. And especially if you're an existing Captivate user, you may take it out, try it on your next project and to compare. If you are interested in trialing the MS60, we have our contact details, so you can contact Leica Geosystems Australia and New Zealand, in addition C.R.Kennedy, as well as Global Survey. Or if you want to try the MS60 today, you can also request via the chat function. And that brings us now to our Q&A. As a reminder, if you have a question that you have not yet submitted, please enter it in the Q&A chat box and we'll get through as many as time allows.
Okay, I can start. I've got a good question already, came in quite early. I apologize, actually, it's something I probably should have mentioned. The question is, how is the scanning speed affected by where you choose to store the data, like be it on the CS remote itself or on board the Multistation? And actually, it does have an impact, which is why it's such a good question. If you start the scanning from the Multistation itself, then you can have access to that full 30 kilohertz mode, that 30 points per second. Whereas if you instigate it all from the controller, then because we're having to do the over-the-air transfer, then the maximum rate you get over the air would be the 8 kilohertz mode. So to get the full 30, you're going to want to be instigating the scan from behind or from onboard the Multistation. But then you've still got that 8000 mode if you're remote. So it's still a significant step forward in speed anyway there. But for sure, the very fastest you're going to want to be using the Multistation. We had some questions about the scanning speed, like how has it been able to jump from 1000 points to 30,000 points, yet still be an MS60? Again, this is a good question. Yes, it's an MS60, but it's a new one. It's a new MS60. It's got different hardware or improved hardware and software. So in terms of the hardware, we're really looking at new electronics, new processors that leverage the latest technology available, allowing us to run a few things a little differently. This essentially is providing us with the potential for faster speeds. And then the new software algorithms I mentioned, they're what unlock this potential and allow us to sort of deliver that high speed. And together, these are combining to give us this large gain. Just looking through a couple of others that come in. One about specifications in terms of the distance and accuracy specifications. So it's still the same Multistation, it's still the same MS60 total station performance wise. We're still seeing that 2000 meters for reflectorless. We're still seeing that 10 kilometer range or up to 10 kilometers for prism. And we're still providing this 1 second instrument. That total station accuracy transfers across to the scanning accuracy as well, where we're delivering the same scanning accuracy as we have before. Any of yours jumping out for you, Jane?
Yeah, I've got a couple of questions about software. Question from Mark, who's saying, what software do you need to register, view, use, analyze, and point clouds? Essentially, when you're exporting the data from the MS60, generally you'd either export from a DBX or an XML format into Infinity, or you can also export the XML format into Cyclone. And this XML format has the images and all the scans included. So you don't really need to register it because the scans are associated with the total station data. So they're all sort of come in, all linked together. So that sort of registration is not really something that's required because they're fixed to the total station setup. So it's not required from there. Which also ties into another question I had, which was, can I have a free trial of Infinity? Yes, certainly. If you're having a trial of the MS60, you'll get a trial of Infinity to go with that. And then you can have a look at the downloading the software and working with the point clouds. And there is actually tutorials within the software which show you how to do it. So you can work your way through the data and we can also assist from there. So yeah, so if you're after a free trial of Infinity, then yeah, contact us on the email addresses that were shown before. Have you got any others, Richard?
Yeah, I got a couple. So I answered questions about the sort of total station accuracy, and I said that total station wise, you're seeing the same accuracy as with the previous MS60. But I also had a couple of questions about the scanning accuracy. What range could you would results become unreliable? How does it compare to P series and other scanners? Things like this. Now, actually for the scanning, we typically talk in range noise, and the range noise varies by the speed that you use for your scanning. Because when you're doing the scanning with the Multistation, you can choose the speed from 1 Hertz up to this 30 kilohertz. The range noise, of course, differs depending on the different speeds. So at the absolute fastest, we're looking at a range noise of 3 millimeters at 50 meters. But very quickly, as we slow that down a little, for example, at the 8 kilohertz mode, we're looking at 1.5 millimeters at 50 meters. And if we slow that all the way down, we actually go sub-millimeter range noise at 50 meters. So if accuracy for a certain area is critical, then you can absolutely slow the scan down for that. And then that means that we're not really dealing with what range does the accuracy change so much. It's a lot to do with what speed. So if you've got a small area that needs higher accuracy, then I would do an additional scan of that area, because you can set up several scan windows. So you could do a larger band scan with high speed and maybe lower density, and then pick out some key areas where you want to do higher intensity, slightly slower scans as well on top of it. You can set up all of these scan definitions and then press go, and the instrument will do each of them. So you don't have to define one scan area, scan it, define the next scan area, scan it. You can define several scan areas, then press go whilst you go and operate another task, go and do something else, whilst it takes just a few minutes to complete those scans. But that way you can be sort of more efficient. You know how I once heard it described as a half-man total station. We went from 2-man working to 1-man working. Now we can go to half-man working, because you can set it up, press play, and then go and complete some other tasks. Any more come in?
I've got a question here from Shivam, hopefully I pronounced that right, about using the MS60 in underground mining and tunneling. And for me, I think that's sort of one of the applications where it really, it's really good because of the tight control which is required. Again, as I mentioned before, using the Travis program. And I've seen some amazing scans coming out as well of tunnels, and because you can do your analysis of the surfaces while you're down there, and you can load up your DXF or load up your your design surfaces. For me, it would be a really ideal tool, because you don't want to have to get halfway through a job and then go back up to the office to do some of the analysis. So certainly, yeah, working in underground mining and tunneling, I think is would be a really strong application.
Okay.
There's another question from Michael that's just popped up, which I think was asked yesterday. Can we use, is Infinity required to load an IFC file into Captivate? Yeah, we were asked this from South Australia as well. No, you can actually load an IFC file as a background CAD in Captivate. So if you go into so you don't import it as such directly into the job, you upload it as a background CAD file, and then you can access that information from the background map if you need to. So yeah, you don't need to have Infinity to upload an IFC, but you can work with it. Sorry. While I've got the mic, there's a question about it being intrinsically safe. There's lots of different requirements in different places for instruments to be intrinsically safe. And again, it depends on where you're working. If you give me your details, and I'll contact you directly. I think it's something that we have the information that we can give you, and it depends on where you're working to how sort of much that fulfills the demands.
Okay, yeah, I've got a couple more came in. One about when we pause a scan. So I mentioned that during my part that we can pause a scan and then come back to it later on. Perhaps maybe I wasn't completely clear, but that pause in a scan does not lock up your instrument. It doesn't mean that the instrument's in pause mode waiting to continue on the scan. It frees up the instrument, actually. You can continue with other tasks. You can be doing feature surveys. You can do other work with that same instrument, and the scan is just put in the scan knows where it was. You can continue to do other work and then later on jump back into scanning and continue to scan from where it left off. So it doesn't lock the instrument. The instrument's free to use other things. Another question, does the Multistation have a GNSS receiver built in, and where does this sit? So no, not really. It doesn't have one built in. Yes, if you have the locate tool, then that does have a GNSS within the sort of panel for the locate, but that's different. That's for asset management. When we talk about the Multistation having GNSS compatibility, we mean that it can work directly with our GNSS antennas. They can connect to it, sit on top of it, and they work as one, writing data into the same database, being controlled by the same interface. So it's this GNSS compatibility. So it's survey GNSS compatibility rather than survey GNSS integrated into the housing itself. Let's see. A question about auto height and the spot size of the laser. The diameter of this laser is actually 2.5 millimeters at an instrument height of 1.5 meters. And that will work with any tribrac that's working with your laser plummets. So it's not a special tribrac to make this work, it's actually integrated into the instrument itself. Yeah, from my side, there was a question about using the mini prism. Yeah, the mini prism depends on ranges, but in general, it's not something that we guarantee with power search and therefore with dynamic lock. So it's more for the full size prisms rather than the mini 360. It doesn't mean it's banned from use, but it's not a performance that we'd guarantee the same way we would talk when we're talking about the full size 360. And that's all the ones that currently sit on my panel.
Right, and I think
any more there.
Yeah, I think yeah, I don't have any more on mine.
yeah, and I think we're just right on time. So thank you, Rich and Jane. That's some great discussion there. So I think this concludes our webinar, and thank you everyone for attending today's webinar. You will be receiving a follow-up email with a link to view the recording of today's webinar. And as you exit today's webinar, please take the time to complete our short survey. We appreciate any feedback you have on today's webinar or any upcoming topics you'd like to hear about. And on behalf of Leica Geosystems, C.R.Kennedy, and our presenters today, thank you for joining us and enjoy the rest of your day. Goodbye.